Orography is the study of the topographic relief of mountains, and can more broadly include hills, and any part of a region's elevated terrain. Orography falls within the broader discipline of geomorphology. Uses. Mountain ranges and elevated land masses have a major impact on global climate. For instance, the elevated areas of East Africa substantially determines the strength of the Indian monsoon. In scientific models, such as general circulation models, orography defines the lower boundary of the model over land. When a river's tributaries or settlements by the river are listed in orographic sequence, they are in order from the highest to the lowest a main stem. This method of listing tributaries is similar to the Strala stream order, where the headwater tributaries are listed as Category 1. Orographic precipitation. Orographic precipitation, also known as relief precipitation, is precipitation generated by a forced upward movement of air upon encountering a physiographic upland. This lifting can be caused by two mechanisms: the upward deflection of large-scale horizontal flow by the orography, the anabatic or upward vertical propagation of moist air up an orographic slope caused by daytime heating of the mountain barrier surface. Upon ascent, the air that is being lifted will expand and cool. This adiabatic cooling of a rising moist air parcel may lower its temperature to its dew point, thus allowing for condensation of the water vapor contained within it, and hence the formation of a cloud. If enough water vapor condenses into cloud droplets, these droplets may become large enough to fall to the ground as precipitation. In parts of the world subjected to relatively consistent winds, a wetter climate prevails on the windward side of a mountain than on the leeward side, as moisture is removed by orographic precipitation. Drier air is left on the descending, generally warming, leeward side where a rain shadow is formed. Terrain-induced precipitation is a major factor for meteorologists as they forecast the local weather. Orography can play a major role in the type, amount, intensity and duration of precipitation events. Researchers have discovered that barrier width, slope steepness and updraft speed are major contributors for the optimal amount and intensity of orographic precipitation. Computer model simulations for these factors showed that narrow barriers and steeper slopes produce stronger updraft speeds, which, in turn, enhanced orographic precipitation. Orographic precipitation is well known on oceanic islands, such as the Hawaiian Islands and New Zealand, where much of the rainfall received on an island is on the windward side, and the leeward side tends to be quite dry, almost desert-like. By comparison, this phenomenon results in substantial local gradients of average rainfall, with coastal areas receiving on the order of 20 to 30 inches per year, and interior uplands receiving over 100 inches per year. Leeward coastal areas are especially dry, less than 20 in per year at Waikiki, and the tops of moderately high uplands are especially wet, about 475 in per year at Waialeao on Kauai. Another well-known area for orographic precipitation is the Pennines in the north of England, where the west side of the Pennines receives more rain than the east because the clouds are forced up and over the hills and cause the rain to fall preferentially on the western slopes. This is particularly noticeable between Manchester and Leeds, where Leeds receives less rain due to a rain shadow of 12 miles from the Pennines.